Hello students, today we are going to talk about mean absolute deviation. Mean absolute deviation is one of those statistical terms or things that you might use when you're looking at data and trying to compare it to something else. Now in the past you might have learned mean, median, mode, range, other ways to look at data, and today we're going to use mean absolute deviation. And we need to clarify some vocabulary first of all. Mean, you'll remember, is the average. And I think we all know how to find the average. Add up a series of numbers and divide by the number of numbers that we added together. That's the mean. Okay? Absolute comes from absolute value. The absolute value of a number is the distance the number is from zero. It is always positive. And the reason it's always positive is because the distance is always positive. I can't have a negative distance. I can walk backwards, but that doesn't make it a negative distance. That means I'm just still so far away from where I started. So the absolute value is the distance a number is from zero, and it's always positive. For example, if you look on a number line, I'll just draw a quick number line. I'll put -4, -3, -2, -1, 0, 1, 2. If I look at this, I can find the absolute value of each of these numbers. What's the absolute value of -3? And we put bars on it like that. Those are the symbols for absolute value. The absolute value of -3 is the distance that 3 is from 0. How far is 3 from 0? Well, it's 3. So the absolute value of -3 equals +3. Again, all absolute value answers are going to be positive. So let's look at the 2. What is the absolute value of 2? Well, how far is 2 from 0? It's 2 spaces. So, I know you can't see that on the TV, so I'm going to write it over here. The absolute value of 2 equals 2, because 2 is 2 spaces from 0. So once again, with absolute value, it's always a positive number. How far is it from 0? Now that we know those two vocabulary words, we're going to talk about all the steps that it takes to find the mean absolute deviation of a set of numbers. So here's a sample problem that we're going to look at to learn how to find this mean absolute deviation. So I have the maximum speeds of 8 roller coasters found around the world. 58 miles per hour, 88 miles per hour, 40 miles per hour, 60 miles per hour, 72 miles per hour, 66 miles per hour, 80 miles per hour, and 48 miles per hour. So in this process of finding the mean absolute deviation, the first thing I have to do is to find the mean. And a mean is the average, so I would add up all those numbers and divide by 8. And when I do that, I get the answer of 64. Now I'm not going to do that with you because you've done that before. Put them in a calculator, divide by 8, and there's your answer. You won't typically always get a round number like this. You may have to round it to the 10th or the 100th, but for right now we'll just use 64. So that's step 1. Step 1 is to find the mean of all of our data. The second step is to find the deviation, the absolute deviation. From the mean. So what does all that mean? I need to find the absolute deviation from the mean, which means I need to find the distance that each one of these speeds is from the mean. So how far away is 58 from 64? And it may help to put it on a number line for you. It may not. I'm going to show you on a number line. You can choose to use it or you can choose not to. Okay? So we know that 64 is going to be somewhere in the middle. So I'm going to put a star on 64. And then I'm going to fill in all the others. I have a, and I really don't care about spacing on this. I'm going to put them just in the correct order. They may not be correctly spaced apart. So I have 66. I have, what comes after 66? 72. I have 80, and I have 88. And over on this side, I have 60 and 58, 48, and 40. Okay? So I'm going to put a star there. I'm going to put a box around that one because that's my mean. Now I need to figure out what is the distance between each of these to the mean. So from 40 to 64, that's 14. From 48 to 64, that would be 16. No, 12. That's not right either, because that's wrong. From 40 to 64 is 24. 64 minus 48 is 16. 64 minus 58 is 6. 64 minus 60 is 4. So the absolute deviation from the mean for each one of these is listed. Because 64 minus 40 is 24. 64 minus 48 is 16. I think I did that correctly. 64 minus 58 is 6. And 64 minus 60 is 4. And I'm going to do the same thing. How far is it from 60 to 64? 64 to 66? 2. From 64 to 72? 8. From 64 to 80 would be 16. And then from 64 to 88 would be 24. Is that right? I think I calculated all of those correctly. Yeah. So these, again, are my absolute deviation from the mean. Step 3. Find the mean of the deviation. So I'm going to find the mean of all of these numbers that I just found. So I add up 24, 16, 6, 4, 2, 8, 16, and 24. And then I divide them by 8. And when I add them up, I get, that's 40, and that's 40, so that's 80, 90, 100. I get 100 divided by 8. And when I do 100 divided by 8 on the calculator, I get something in the neighborhood of 12, something, something, something. I should get a calculator to do that, but I'm going to look at my handy-dandy cheater manual. And it becomes 12.5. So the mean absolute deviation of all 8 of these roller coaster speeds is 12.5. What is that number used for? That just tells me the average distance each one of these is from the one that's in the middle, or the mean. The next example we're going to look at to find the mean absolute deviation is the average speed of 10 birds. So I have the speed in miles per hour of 10 different birds from 88, 77, 65, 70, 65, 72, 95, 80, 106, and 68. Again, those are the average speeds of 10 different birds. Well, what is the mean absolute deviation? How close are they to the average of all of those birds? So step 1 is to find the average, or the mean. So I plugged all of those into my calculator, divided by 10, and I got 78.6. So the mean of this set of data is 78.6. Now you'll remember step 2 is to find the absolute deviation. I'm not going to use a number line for this one. I'm just going to subtract all of these by 78.6. And if I get a negative number, I just change it to positive. That's the way we do standard mean absolute deviation. So 88 minus 78.6 is 9.4. And 77 minus 78.6 is it's negative 1.6, but I'm using the absolute value, so I just write down 1.6. And then 65 minus 78.6 is 13.6. It's actually negative 13.6, but I change it to positive. And then 70 minus 78.6 be 8.6. And then 65 minus 78.6, and I get another 13.6. I guess it was right there. I could have written it down. And 72 minus 78.6 is negative 6.6, but I just write down 6.6. And then 95 minus 78.6, and I got 16.4. And then 80 minus 78.6, and I got 1.4. And 106 minus 78.6, and I got 27.4. And then 68 minus 78.6, and I got negative 10.6, but I just write down the positive because we're talking about absolutes here. So here are my 10 deviations, okay? 78.6 was all of these numbers away from the original numbers. Now I'm going to find the mean of this set of data. 3 mean of deviations. So I add all those numbers together. 9.4 plus, 1.6 plus, 13.6 plus, 8.6 plus, 13.6 plus, 6.6 plus, 16.4 plus, 1.4 plus, 27.4 plus, 10.6. Enter. I get 109.2. I divide that by 10, and I get 10.92. So the mean absolute deviation is 10.92. And that's not on the TV, so I'll write it down here. 10.92. 3 steps. They're not difficult steps. They just take a long time. 3 steps. Find the mean of the set of data. Figure out how far each of those data points is from that mean, and then find the mean of those numbers. Mean, distance, deviation, mean. For your practice problem, what I'd like for you to do is to find the mean absolute deviation of the number of daily visitors to the museum. Over the last 5 days, they've had 112, 145, 108, 160, and 122 visitors each day. So will you please use the 3 steps and show those 3 steps? Find the mean, find the absolute deviation, and then third, find the mean absolute deviation of these 5 numbers. You'll probably have to round to the nearest hundredth on these. So please round to the nearest hundredth. Take a picture of the whole process. Submit it through Edmodo as your practice problem.